Hello again. We're going to talk about more Venn diagrams, and this time we're going to use a little bit of algebra. We're going to put numbers in those regions that represent the number of elements that are in each region. So this is lesson 5.6. Let's get started. We start with two sets, A and B, and you can see that there are little numbers in parentheses in every possible region of this diagram. Okay? So let's talk about what they mean. Well, how many elements are in A? Well, I see that there are 7 elements in set A that are not in set B, and then I see 3 elements that are in set A and in set B. So the total of those, the 7 and the 3, would give me 10. Okay. How many are in the union of A and B? Well, I need to look at in every number that is either in set A or in set B or in both. And that's the 7, the 3, and the 5, so that's 15. And how many are not in B? So I need to look at every number that is not in B. That's the 7 and the 4, so that would give me 11. How many are in set B but not in set A? So I need to count every number that is in set B but not in set A. And that's just that 5 right there. All right, so that's kind of how those numbers work. And obviously, since we know a little bit of algebra, we can use variables instead. So if I know that the number of elements in the entire universal set is 30, and if I know that the number of elements in set A is 14, and the number of elements in B is 17, the number of elements in the intersection is 6, then I need to find the values of A, B, C, and D. I have 4 pieces of information, and I have 4 variables, so that should be plenty to help me finish the job. Okay, well, I know that since the intersection, the number of elements in the intersection is 6, that means that letter B is 6, so I can fill that in right away. I also know that the number of elements in set A is 14, so the A that's in set A and the 6 that's in set A, those add up to 14. Well, that means that letter A must be equal to 8. I also know that the number of elements in B is 17, so the 6 that's in the intersection and the C that is not in the intersection, those have to add up to 17. Well, that means that C has to equal 11. Okay? And lastly, I know that there are 30 elements in the entire set, so that means that the 8, the 6, and the 11, plus that little D that's sitting in the corner, all of those have to add up to 30, and so that means that D would have to equal 5. And so that's how you use a little bit of algebra to figure out any variables that you would have in a Venn diagram. We're going to use this in problem solving, obviously. It's kind of a nice segue to that, but we'll talk about it in the next lesson. And if you have any questions for me, let me know, and I will see you tomorrow.